And welcome back to my YouTube channel. Today I want us to discuss about what is a voltage. Actually, what is a voltage? What is the voltage? I want to know what is a voltage. As you can see there, what is a voltage? A voltage uh, is simply the energy transferred per unit of charge. Voltage is simply equals to the energy transferred is equal to energy transferred is the energy transferred must know that per unit of electrical charge, right? Maybe you can say, yes, you can, maybe you can say in a conductor there is no problem and be specific. So as you can see, this is the same. It's also known as potential. It's also known again as a potential difference. Also known as a potential difference. As you can see, voltage is what is the energy transfer per unit of charge. That means voltage is equal to energy transferred per unit of charge. Okay. This is what is simply just the work that is done. W represent our energy, which is simply just a work. You understand? So that is a voltage. In actual facts, here you can see that means voltage is simply just 1 joules per coulomb, 1 joules per coulomb, whereby work is measured, energy, its SI unit is measured in joules. So voltage is joules per coulomb. That means 1 coulomb of charge, 1 coulomb of 1 joules over 1 coulomb of charge is simply equals to what? This will give us voltage. Will be voltage, right? So this is what we know. So let's say we are given a resistor. Let me just say point here. We have a resistor here, which is R, and point B. Let's say here we can say point A, here we can say point B. Let's say now at point A, we have at point A, let's say we have 12 volts. At point B, we have 8 volts. So what is the potential difference across this resistor? If you have given like this, what is the potential difference across this resistor? We simply is called the change in voltage there. What is the potential difference across this resistor? The will simply just equals to the change, would be the change in voltage will be 12 minus 8, which is when you minus 12 minus 8, right, which is 4 volts, right? That means there will be 4 volt. 4 volts will be doing work here at a resistor form. That will be 4 voltage, right? So that is what you must understand. So let's say now we have a resistor. Now it's placed vertically. So I have the resistor here. I have point A. Here I have point B, right? So here, let's say here I have 16 volts. Here I have 9 volts. So which direction that the voltage will, which direction that the voltage will, or the charges the charges that will travel or will flow. So you're supposed to know that okay, let's say in a conventional current, the conventional current, the voltage drop will take place, always flow from the voltage or current is always, the current is always flowing from what? From high potential to lower potential. Here you see 16 is high. This is high, right? It's a high potential. 9 is lower potential. It's a lower potential. So um will always flow from high potential to a lower potential. Then the electrons will flow in the in the opposite direction. Here will be a current that is flowing from low potential to from higher potential to a lower potential. And you must know, yeah, this is what you're supposed to know. So let's say now you want the difference of, yes, the resist, what will be the voltage of resistor R? There will be a difference, will be 16. 16 subtract 9 will simply equals to what? Voltage at R will simply equals to the 16 subtract 9, which is simply 7 volts across that, right? That is what you're supposed to know. So yeah, this is what you're supposed to know. That is how, let's say now a voltage, let's say given your circuit like this. For example, you have a resistance. Here we have a 12 volts. Here we have a resistance. So what you're supposed to know, electrons will flow from a negative terminal. This small one, this you see, when you see a small bar, it's a negative terminal. A long bar represents a positive terminal. Electron will flow from negative terminal and then will go to positive terminal. You must know this. But the current will flow in the opposite direction. Coefficient current most flows from positive terminal to negative terminal. So you understand this, right? So yeah, guys, so that is what you're supposed to know. So here I've given question 7. I want us to put that into work. It says consider the following circuit below. The okay, remember the charge is equal, is coulomb. Charge is measured in coulomb. Work there, energy is measured in joules. I'm supposed to explain. Then this is simply just a coulomb, which is the charge, right? So here, question 7, you're given, consider the following circuit below. Says, reading on a voltmeter V1 is 6 volts on the V1. You've given there, but this is 16 volts. The ammeter reads 1.5, sorry, 1.5 amps, right? So they say 7.1. Define the potential difference. I've talked about you. The potential difference is simply equals to what is this? Is the energy transferred per unit of electrical charge. Here you can see energy transferred per potential difference is simply just energy transferred. W means energy transfer per. This is measured in joules per coulomb, which is charge. This represents charge. You see. So is the energy transferred per unit of electrical charge, right? So that is our potential difference, right? So here 7.2 says calculate the magnitude on V2. We want the voltage. If we have given a work there, 8,000 joules of energy, we've given an energy is used by 735 coulombs, right? You have given those things. Here we have given W, which is our energy, and then we've given the charge. Remember, it's measured in coulombs, the charge there. So without wasting time, you know that voltage is W, which is energy over, as I've explained, is energy over charge, right? So you know what is your, remember your your energy here is 8,000 joules, as you can see. Then your coulomb, your charge is 735 coulombs. As you can see, this unit here is simply joules over coulombs. Is simply equal to what the voltage there. So yeah, it's what I want to see there. So yeah, this will have 8,000 over 735. This is simply equals to, punch that on your calculator. On our calculator, I can say 8,000 divided by 735, right? This is simply equals to 10,88 volts, right? Volt, which is, this is what we have there, as you can see, guys. So yeah, this is what you're supposed to know about the voltage for now. This is what you're supposed to know about voltage. Then in the next coming section, we'll discuss about what is a current actual. We'll discuss about current. So this is what we'll discuss about. So for you to not miss this session, please, on your top there, guys, there is a subscription button. Just subscribe. After subscribing, click the notification button. They'll show the bell. Click that bell, that is a notification button. Then you'll be notified whenever I post a new video. You can share this to your fellow classmates. And thank you for watching, right? Have a nice day then.